Okay, so welcome to the AI Agent Montreal meetup. Today we have the amazing opportunity to have Carl Lapierre. Just a little reminder about the meetup. We are people curious about AI, and we want to demystify AI and tool and tech trends around it. And we want to share and spread best practices around it. And the talk of Carl, how to instrument, govern, and debug agents before they go rogue, is perfect for that. Just for the organization, the talk is recorded and I will share it on our YouTube channel. Feel free to see it again. Feel free to ask any question in the chat and we'll try to answer it along the presentation or at the end, depending on you, Carl. And that's it. The place is yours, Carl. Thanks to be with us and you can start.
Okay, thank you very much. Uh, first and foremost, do you see my full screen with my tabs
Yes.
if I go out? Sorry.
Yeah,
Do you,
everything is good. Yeah.
with the tabs as well?
Just
Yes.
yeah.
All right. And if I'm in presenter view, sorry, do you see, am I sharing my presenter view or still the tabs? Because
Yeah,
I'd
we
like
See the
see
to,
we
tab.
see all the tabs.
okay, perfect. Well, that'll be fine because I need to switch over to other tabs as we go. So I'm just going to full screen
Okay.
this and yeah, okay. So, thank you very much. This is a presentation that I'm doing for NDC London next week, and I wanted to try it out at first. So if you're listening to this or seeing this online, that's the first time that I'm giving it out, and there's going to be a feedback form at the end for you if you want to provide some. I would happily want to know if you'd enjoyed it or not. Um, so let's get started. How to instrument, govern, and debug agents before they go rogue. Very, very important topic these days because agents do go rogue quite a bit. But first, I'm going to talk a bit about myself. My name is Carl Lapierre. I'm a tech lead and a solutions architect from Montreal, Quebec. I've been doing this for over a decade now. I work at Ocidia, which is an innovation firm that specializes in AI in robotics, especially like in everything that's like healthcare, manufacturing, and mining. Um, but more specifically at Ocidia, I specialize in designing solutions for agentic systems. I've worked on quite a few in the past 3 years, ever since that LLMs have essentially gone mainstream. Um, and a few of those have made their way to production, which is quite a pain when that happens because now you have to maintain them. And that's sort of the experience we're going to talk about in a bit. Just to talk a bit about some of the projects that I've worked on. These are some, street credentials, a lot of like tinkering projects, but there are more serious projects that I've worked on more recently with Genius ERP, which had to do with integrating assistants in manufacturing ERPs. And those ones are in production and have been going through their own set of challenges. And with all of these projects that I've worked on, I can confidently say that uh, agents are terrible. They're pretty difficult to work with at first. So they're not all that terrible. It's just that at first they're not necessarily like production ready, and you have to constantly work on them because agents are compound systems, right? They're made up of a bunch of different tools, a bunch of different AI models. They deal with various contexts coming from third parties. They're also continuously evolving. Uh, New models are being released every week. You're constantly updating prompts to support new use cases. You're also integrating new tools to extend their capabilities. And third, they're also sharing accountability, not just with the agent, but you're also sharing accountability with the users and the tools that it's using. Users have their own way of bringing in their context. Tools also have their own way of bringing in their context. Retrieved data might change over time. It might be ambiguous. So all of these are increasing the amount of issues that you can encounter when you're dealing with agentic systems. I'm getting a bit ahead of myself though. So first we're gonna just go over the agenda for today. Um, I split this into three parts. One of them, the first part is why we need to observe and govern agents. Part two is how to collect structured agent telemetry, and part three is what we want to observe and how to evaluate them. And then we'll also do a little quick demo, and hopefully we have enough time with questions at the end. What we won't cover is how to improve your agent's architecture. This is mainly focused on how to get your data from A to Z and what to do with it once you have it in like an observability platform.
Just if you have a question, you can ask it in the chat, but we'll answer at the end.
Yeah, thank you. And let me know if there's a question in the chat because I can't see it right now. All right, so quick intro to agents. This is my definition that I like to give around agents. I think it's very convoluted what an agent is for a lot of people. But agents are systems that use large language models to reason on a given context and goal, and then decide on the action to take in order to accomplish that goal. So very simply put, we have an input with a context and a goal. A decision is made, so take an action towards that goal to give an output. And then you can do like you can implement more powerful patterns where you're actually like chaining all of these decisions together. The most basic and well-known pattern in agentic system is reason plus act, where you're basically going through a reasoning step, then a decision that gets taken, which is essentially like what tool we want to use, and we chain all of those together until we get to an answer that we're looking for. And that's basically it. Very simply put, that's an agentic system. But what we want to take away for the observability part is that agentic systems work towards a goal by chaining multiple actions together. These chained actions form a trajectory from input to output. And a trajectory can consist of hundreds of chains and nested actions. And then the more autonomous agents are, the more complex and difficult it is to actually observe these trajectories. So why do we need to govern these agents? Let's make the distinction between agent observability and the traditional observability. Agent observability is fundamentally different from traditional observability because the systems that we're observing are not fixed request responses. They're a decision-making loop that can reason, it can branch, it can call tools, it can retrieve context, and it changes its own execution path at runtime. So traditional observability focuses on infrastructure health, deterministic workflows, latency, errors, throughput, and the shape of the request is like mostly predictable. When agent observability, we need to explain why an agent took a particular action, which context or tools influence the decision, and how like intermediate reasoning steps affected the final outcome. So there's a big shift from something that's like purely operational signals to behavioral and semantic signals. So that's the distinction between both. I like to give this example a lot. It's one of the first agentic systems that you can say that I've worked on, which was back in the prehistoric age of LLMs back in 2022. We made like an emergency hackathon to figure out what we can do with LLMs because it was gaining so much popularity. And what we decided to do was to have someone that can take orders for pizza on the phone. So you could talk to the agent, it would pick off a menu, and then know how to like calculate the results and take your order. And this is that at the time when GPT 3.5 is like the apex predator of LLMs. And there's also a Bard that we don't talk about anymore. And I don't know if the sound is coming through. Can you hear it?
Yeah.
Hey,
Yeah.
what's your
Okay.
favorite pizza here at Open Pizza? And whatever you say, I'll have three of those. Thanks.
Bit of latency there.
As a cashier, I'm not allowed to pick favorites, but the margarita pizza is pretty popular. Your order of 3 margarita pizzas.
Okay. You get the point, but there's a couple of things that went wrong here. Well, not a couple of things, but one thing in particular, it said that it can't actually give out an order and pick favorites when it actually did pick out 3 margarita pizzas and it put it on the board. So there's like a misalignment in how the agent responded and what the agent actually did. And this was really interesting. This is like one of the first like real demos that we did with LLMs. And we kept pushing it a bit further, try to see like what else we can do. We asked it for like gluten-free options, and it came up with the salad combo. It didn't go for the Caesar salad because it has croutons, but it kind of makes you think what else could happen if I asked for like dietary restrictions. Is it actually going to suggest to me something without knowing if I'm like deathly allergic to it or whatnot? So there's a bit of a risk in dealing with those types of agents. And then after we asked it a more like broad question like this,
Hey, can I get one of everything on your menu, please? Thanks.
this one's long as well.
I'm sorry, but I don't think you actually want one of everything on the menu. That would be quite the undertaking, and I
Okay. So this time again, it selected everything on the menu, but it actually told me that I wouldn't be able to eat everything without knowing that maybe I was ordering for a party or something like that. And when I tried again, the exact same question, the second time it told me that it didn't have enough ingredients in the restaurant to make that order. So very, very difficult to work with. At first, the main success path did work properly, and it's the same reason why. Um, Agents are very powerful today is because they're generalists. They can answer to a wide range of questions, but on the other hand, it's what makes them dangerous as well because you can't really catch all the different scenarios that you're opening up to with an agentic system. Um, and this is not just us. It's not just the system that it worked on. There's good examples out there of the big players like Google. In this case here, they answered for a question about cheese not sticking to pizza. They told the user to put glue in their pizza, which is a really popular example, but this is straight up a very bad thing to say to one of your end users. It's a bit obvious though, right? You know that you shouldn't be putting glue in your pizza, but in some cases not as obvious as that. Air Canada had a chatbot in 2022 that um, was consulting with one of their clients, and it was um, telling it that it can ask for refunds based off like a bereavement fare that they were looking for reimbursement. Um, the chatbot assured the client that it could get a refund, and it turns out that the client had to qualify before travel so that they can get the refund. This led to a lawsuit. It led to the client not being able to get a refund, but they ended up winning the lawsuit. Very public news, but just goes to show that these type of hallucinations or misinterpretations of information can lead to very serious results down the line. And it's not always obvious when an LM hallucinates or an agent hallucinates, which is why we need to put proper guardrails in place and observe our agents. So just to wrap up this section, what do we usually tell our clients when the requirement comes in and they say that the agent shouldn't, in under any circumstance, hallucinate or give out wrong answers? We have to sort of break the bubble and pop the bubble and say that the first agents that we're going to develop are going to fail catastrophically. It's impossible to have a perfect agent that doesn't hallucinate or give out any wrong answers at first. What we can do is improve our agents, because improving our agents is an iterative, failure-driven process that requires constant oversight. Improving agents depends on the involvement of subject matter experts to flag inaccuracies and inconsistencies. As a developer, you don't necessarily know if an answer is correct in the domain of your client's knowledge. And then what we say as well is that we want to think about it like as if we're hiring an intern. They go through performance evaluations and feedback rounds to get better. The same thing should be thought of about AI agents. Okay, so part two, how do we collect agent telemetry? Well, we have a wide range of frameworks that we can work with. We have, Microsoft Agent Framework, Semantic Kernel, Pydantic AI. All of those exist for us to build cool agents with, and we have another big pool of observability backends that we can use. Some of the big ones today are like LangFuse, Azure AI Foundry, Arise, opaque. And these are very specific to agentic systems. You still have all the other observability platforms like Datadog or Grafana that allows you to visualize the traces emitted by these frameworks. But if you want to use a specific observability backend that's tailored to agentic systems so that you can do these behavior analysis. So why should we use an AgentOps platform? Like what comes with these platforms that other general observability platforms don't give? Well, for one, agent traces and diagnosis tools. So we have a very special way of visualizing the execution change that our agents are going to take to get to a response. We're going to see like this waterfall design, which is very similar to other tools, but they're specifically made to visualize the telemetry attributes that come from GenAI semantic conventions. Another one is agent metrics, having a way of knowing how many inference calls were made, how many tokens were consumed, and also giving like an estimate on the cost of an agent or an agent superstep is an important thing to have. Also, we have prompt management, so a way to decouple the prompts from our system so that we can iterate over them, include different versions of our prompts, do some A/B testing and evaluations on different configurations. Prompt management is a big one. We have a way to manage data sets as well. Data sets are ways to collect traces into a structured container so that we can use to run experiments on. And we can also use these data sets to fine tune our agents later on, but that's more of a experimental thing. And probably the biggest attribute of these platforms are the ability to score our traces and observations. So with LLM as a judge or with human annotators, we're going to be able to give out specific scores based off different evaluation criteria to our traces, and we're going to be able to view them and diagnose the issue that comes with our traces. So we're going to do a demo of this in a bit, and hopefully that'll clear things up in terms of evals. And last but not least, annotations. So having a human in the loop interface for grading, real world interactions and evals. So again, when it comes to things like retrieval augmented generation, sometimes the retrieved context might not be relevant to you. You might not understand that some of the content is ambiguous or wrong. So you might want to be sending that to a subject matter expert for downstream analysis. And they can annotate these results and determine if it's a hallucination, if it's a bad retrieval, and you essentially get a curated data set of questions you can use to reproduce these hallucinations. Annotation is really important. Not all platforms offer annotations, but in our case, we're going to be using LangFuse, which does support annotations. This turns into the eval lifecycle document here, the diagram that you see here. We're going to come back to this at the end of this, the second part. For evaluations, we're going to go over what this lifecycle looks like. So getting the data in the platforms, it's actually quite simple. What do all of these frameworks and observability platforms have in common? Well, they all use OpenTelemetry. They're all built on top of OpenTelemetry since the start of the projects. OpenTelemetry has a huge track record since mid 2000, like in 2015. It's been a widely successful project. So all the greenfield projects that have come out since have all decided to adopt OpenTelemetry, which is great. Because what OpenTelemetry does is act as a vendor-neutral open source observability framework that's focused on the generation, the collection, management, and export of telemetry data, such as traces, metrics, and logs. The key part here is that it's a no vendor lock-in way of collecting data and sending it to an observability backend. OpenTelemetry is focused on collecting data and correlating metrics, logs, and traces together so that you can tell like a whole story on what happened in your system. The key aspects that I want to cover for these agentic systems are, we'll start with traces, but we're not going to cover like all of the what OTel offers, but what we're going to be using in the demo today. So for one, traces, they're a representation of a single superstep moving through an agentic system. So if you're thinking about it like you're having a conversation with an agent, um, every message that you send to an agent equates to one single superstep that will trigger a chain of reasoning in action. So that would be the equivalent of one trace. And then you will have this waterfall visualization when you're visualizing traces that show you everything that's happened within that trace. With traces, we have spans. Spans are the fundamental unit of work within a trace. They're really the building blocks of the trace. And with spans, we have a start and an end time, and we can set attributes to these spans. And they can be nested in a hierarchical relationship. So every span has a parent, but also a trace ID. And then these spans can be sent out individually, and they can be correlated with the trace that it was related to. And that's how we have like a hierarchy of spans. There's also an important concept in OpenTelemetry for when it comes to context propagation. So without context propagation, the trace just breaks. It's how one service knows that the work belongs to a request that started in like service A. So you can propagate OpenTelemetry context across multiple services, and that's where OpenTelemetry like really shines for distributed tracing. What it allows us to do for agents, let's say, is trace a series of reasonings and steps through like MCP clients, clients and servers. And yeah, that's basically it. So a full trace of the agent's behavior can be seen across many different systems. There's also the concept of the OpenTelemetry collector. So it's a vendor agnostic proxy that receives, processes, and exports telemetry. You can send data directly from your app to an observability backend, but the collector is recommended for production and relieving some of the back pressure off your system so that it's not focused on sending out telemetry data. It allows you to do a couple of other things as well. So it offloads the responsibility, but it also centralizes credential management. It allows for filtering some of the data and transform them before they go into your observability backend. So usually the steps of a collector pipeline goes from receiving the data emitted from your app to processing it. So that could be batching it or removing some of the PII or altering some of the attributes that are assigned to a span, and then sending out to an exporter, which will bring it to the backend of your choice. You can deploy this as a sidecar. You can deploy it as a gateway. There's many different configurations that you can have for a collector. You can have chains collectors together as well. It's up to you on how you want to manipulate some of that data. And this is sort of what the OpenTelemetry stack is going to look like. You have your application code that implements is instrumented to interact with the OpenTelemetry API. The OpenTelemetry API has tracer providers, metrics providers, or log providers implemented via the SDK. That sends data over to the OTel collector via OTLP protocol. And then the same thing can happen with infrastructures. So AWS and GCP might have services that emit telemetry that you can capture. Same thing for client instrumentation and the databases that you use and APIs, they can emit telemetry as well. And you can capture that and bring it all to an observability backend under the same linked context, basically. So on the topic of instrumentation, most of the libraries that we're going to use for agentic systems are auto-instrumented. That means that you don't need to do anything and they emit telemetry by default that you can capture. Other other frameworks offer ways to hook into callbacks that allow you to set up instrumentation. So let's say, for example, LangGraph has some callback functions, and LangFuse has an SDK you can plug into LangGraph so that you can collect that telemetry and then send it over to an observability backend. And that allows you to collect telemetry in just a couple lines of code. On the other hand, you can do manual instrumentation, which is what I want to talk about today. And this is about creating custom spans in your code. Custom spans that you can enrich with your own span attributes. And doing this allows you to have more context when you're doing agent evaluation, which is really important because 85% of detailed case studies forego third-party agent frameworks, opting instead to build custom agent applications from scratch. So this comes from a report from IBM called Measuring Agents in Production. It came out 2 months ago. And I've seen this many times as well. We've adopted a couple of these frameworks in the past, and usually what happens is that we're trying to engineer our way around a framework, and that leads to like more fragmented and missing telemetry. So chances are that you will be instrumenting your own code to send that telemetry to these observability backends. And it's actually quite simple to do. So let's jump into that right now. First, we need to learn about semantic conventions. Semantic conventions are like a standard naming scheme for common operations and attributes across all languages and frameworks. So the problem without semantic conventions is that one system might report on like HTTP methods like a get with HTTP.method as their key. And like another application, you might just get method. And when it comes to aggregating those results in the observability backends, it might miss out on some of these attributes because they're not named properly. So we want to have a shared vocabulary that all our systems speak in, so that we end up having like a standard and interoperability between these systems. There's a GenAI semantic convention that's been it's been in development for the past like year and a half, I would say. The GenAI semantic convention is maintained by OpenTelemetry, and its main goal was to focus on inference tasks, GenAI inference tasks. That's why you'll have more specific key value pairs that are dedicated to like the system that you're using, the requests and the model that you're using, the how many input tokens and output tokens. They're very like inference specific. And a reason why, again, you would need to have a standard for the values that you would use. Let's say I use GenAI system with paired with OpenAI. That would allow observability platforms like Opaque or LangFuse to pull a pricing sheet and get like the token costs, or even pair it with the model so that it knows like how much it actually costs for a specific operation. But if you weren't using these standards or these attributes, then you wouldn't have this metric information. There are other semantic conventions out there for agentic systems. Of course, nothing is perfect. Some semantic conventions like OpenInference just move faster than the OpenTelemetry GenAI conventions, which were more focused on inference tasks, like I was saying. So OpenInference focused more on workflow and agent-specific attributes. And as like teams started building agent loops, chains, retrievers, tools, and evaluators, they needed to share semantics again, and they needed to share it now. So they front run the GenAI semantic conventions and created the OpenInference one. So it's sort of there to add on to the GenAI semantic conventions, but they do have their own definitions, which are completely different. In this case, like we're seeing here, GenAI semantic conventions have for system have the word system, when in OpenInference they have the word provider instead. So OpenInference is more detailed and more experimental, when GenAI is less detailed but more concrete and subject to less change. Right. So another one of the most important attributes in the GenAI semantic convention is the operation name attribute. And this translates to the span kind in Open Inference. And LangFuse has their own way. By the way, I'm specifying LangFuse because that's what the demo is going to be in a bit. But other platforms might have their own way of mapping it. But LangFuse maps the Open Inference semantic convention and the GenAI semantic convention into what they call an observation type. And as you can see in this table, there's a big list in the Open Inference span kind, but in the GenAI operation name, we only have 4 or so that are more inference specific. But we want to support all of the ones that are from Open Inference because they will give out more information on how our agent is going through its various steps in the workflow. So some of them we have some for guardrails and re-ranking, but all of them are very important for evaluations. So this is .NET specific because conference that I'm talking about and I'm talking at next week is in .NET. But we're going to go over how to trace in .NET, how to export the telemetry, and also how to set up a collector. And then we're going to do a demo on all of that. So tracing in .NET. So .NET had a built-in tracing system before OpenTelemetry existed. It's called System Diagnostics.activity. And instead of creating a conflicting class and forcing devs to choose between activity versus span, OTel agreed to upgrade existing .NET activities to be OTel compliant. So that's basically what we see here. So when we want to create an activity source, we'll just declare a new activity source with GenAI attributes .source name, which is just a source name that I've set up, which essentially says what channel to send the events to. And then every time that you are starting an activity, you're giving it a title, but you're also starting a new span. And we're going to get an activity out of this. But we're not always going to get an activity out of it, which is why I'm doing a null check. Why wouldn't you have an activity coming out of this new activity span? Because in some cases, we might have a sampler set up, and sampling basically omits the activity when it's turned on if it chooses not to log that span specifically. Also, if you don't have a listener set up, so if you're not actively exporting any data from the activity or that channel, then you won't have an activity when you start it. And then it's as simple as adding tags to these spans. So in this case, it's a generation span, and we're going to assign what the operation is, which is a chat, who the provider is, what the model is, what the input is. And after that, we're going to return a generation scope. And the generation scope is essentially a wrapper for the activity, but it also comes with a couple helper methods that allow us to set things like output tokens, because we want this activity to stay alive until the chat completion is done, because that's going to give us the start and the end time of the generation span. It'll also allow us to add more tags after the generation is complete. So that's how you send out a trace and a span in .NET. Then when it comes to exporting, it's as simple as this. So at the start of the app, we set up an OpenTelemetry collector. So at first, when we're creating a tracer provider builder, we're creating a tracer provider, which is the core OpenTelemetry component responsible for collecting traces. Then we add a source, which is the channel name that I've talked about when we were creating the activity. You can have multiple sources as well, leading to an OTLP exporter. And after in the OTLP exporter, we're just sending out to a local container, which is a collector that's going to collect all my telemetry. We'll look at that setup in just a bit. All of this is done over gRPC, which is like high performance remote procedure calls for fast communications between our services. Okay, so that leads us to a collector. This is a YAML file that I've set up. This is kind of hard to see on the screen, but there's a lot of text. But this YAML file is basically a configuration that says how we're going to receive our telemetry, how we're going to process it, how we're going to export it. And then at the end, we have a service block that tells us how we're going to bring our receiver, processor, and exporter together into one pipeline. For the sake of this demo, what I've done here is set up a receiver which just receives the exported telemetry I just showed. We have a processor. We have two processors. One is a batch processor that will collect all of the spans and batch them in with a max size of 1024 to our observability backends. We also have a transformer. This is a specific step that only happens when we're exporting to LangFuse, and it alters some of the attributes that are from the GenAI operation name type that's not supported by the GenAI semantic conventions, like chain and a retriever. And I just wanted to demo the fact that you can do some lightweight processing and mapping here. And after this, we have two exporters that are set up. One of them is for LangFuse via their OpenTelemetry endpoint, and then one of them is for Azure Monitor via their specific APM, which is like a connection that's native to the OpenTelemetry collector. And when I'm building these pipelines after that, I'm going to explain that I want to receive, transform, batch, and then send to LangFuse. And for Azure, I want to receive, batch, and send out to Azure. And that's basically the setup for our collector. And now we can talk about the agent that I'm going to demo and do a quick demo. So this is a reasoning agent that's very simple. It does a reasoning step. It selects tools. It has access to either rolling dice, dealing cards, or doing a web search via Tavily. And then we execute the tool, and then we go back to the reasoning loop. And then after the reasoning step can decide to select another tool, or it can decide to answer the question in the end. Okay, so I need to share my screen. I'm going to share another screen real quick. I'm gonna have to jump back after this.
Yes, it's okay.
All right, you see it? And
Yeah.
Is it big enough?
Yeah.
Okay. So if I say something like roll a dice, and my agent's going to think, and it has access to a dice tool, and it's going to give me an output. So you rolled a 2, which is something I was expecting, and then after that, we can exit. So in theory, now my agents should have sent telemetry through the collector, also to LangFuse and to Azure at the same time. And we're going to go back to our screen and look at these logs. Okay. So in this case, we're going to go back here. This is Azure Application Insights. It's a service that I set up to collect, to receive those telemetries. And if I refresh and I look at my last trace, I'm going to see that I have all of my traces here, and I could see a tool that was executed. And if I look through, I can see the name of my tool, which is roll dice, and I could also see the output of this tool. I also see that since I have GenAI properties and they support the GenAI semantic conventions, that they pick up specifically on these GenAI specific properties. But I can go even a bit further when it comes to Microsoft. They have AI Foundry, which lets you point to application insights, and they'll format these traces so that you can view them in a better way, I guess is the way to say it. So this is AI Foundry. It's a full-on AgentOps platform that allows you to build agents directly into this in this service, but also gives you tracing, gives you evaluation tools, ways to put guardrails in place, ways to manage a data set, everything that I've talked about earlier. If I go in here, I'll see a trace and I'll see exactly what we just did. So this was for rolling a dice. I see all the metadata, but I see a nice chain that explains to me exactly what happened with the amount of tokens that I've used. And even then, I can go into my monitoring section and see all of the tokens that I've been consuming with my agents, as well as error rates and the average inference call duration with some nice little graphs. So this is for monitoring and observing in Azure, but that's not what I wanted to focus on. I want to show you, oh my God, LangFuse. Okay. Another observability platform, I get sort of the same tools, but again, a bit more feature ready. I guess they have a bit more features in LangFuse than in Azure. If I go in my tracing here and I open up one of my latest traces, I would see exactly what just happened. So I go through the agent, I do the first reasoning step, and I can see my reasoning behind it. So to roll a dice, I need to generate a random number between 1 and 6. And then the tool selection happens here. So a call to the LLM says that we should roll a dice, and then we reason about the results, and then we output them. So those are the steps to take to collect the telemetry. Now, once we have this telemetry, it's time to evaluate them. This is the most interesting part, I would say, about dealing with this data. We can go back to the presentation here, and I'm going to talk about the different types of evaluations that we can do. Okay, so there's 3 phases to evaluation. Number 1 is manual tracing. So this sort of when you go with the vibe and do like a deep dive into individual traces. That's the very first step when you're developing with these agents. You don't actually have to have everything in place to evaluate. Then you have online evaluations. So when you have your first users that are being onboarded, they'll be doing QA. Maybe they're your subject matter experts. They're going to give you feedback through a feedback mechanism. It could be a thumbs up or a thumbs down. It could be like a 5-star rating system. But what's important is to also collect their comments when you're collecting feedback. And then after that, those can be analyzed in your observability platform. There's also the concept of live evals, which are evals that are triggered automatically when traces come into your system. And we'll show an example of this after. And then finally, there's offline evaluations. So this is when you have an agent in production, you have like all the proper first guardrails in place, and you want to scale this agent. And then we're going to run some automated testing against like a golden standard data set or multiple different data sets to run experiments and evals against those experiments to get a result and hopefully bring up some signals that there's an issue with the agent. Going back to the eval lifecycle, this is what we just talked about. So the agent is at the very left. It leads into 2 different steps. Number 1 is observability, so collecting traces and metrics. Next one is online evals, which we just talked about. It leads into the analysis phase where we're doing root cause analysis. We're handing off some of the traces for annotation. Some of them go through dataset curation that makes their way inside of a data set. And then we move on to an agent improvement step where we're going to even like refine a prompt, change the agent architecture. Once we've done that, we're going to run an experiment against our data set using this new agent. And that leads us to offline evals. Either we have a human doing the verification of that experiment that was run, or we have an LLM, or we have both. They're actually giving scores to the traces that we've recorded based off of those experiments. And based off the results, we might send that off to analysis, or we can also deploy the improvements and then start this loop again for improving our agent. That's the eval lifecycle. There's 3 types of evaluations, and I'm sorry I'm going pretty fast because I just realized we only have 12 minutes left. There's 3 levels of evaluations. Number 1 is the black box evaluation, which is just about evaluating the inputs versus the outputs. We have a trajectory evaluation as well, which is known as like the glass box evaluation, which is about evaluating the journey that your agent will take towards its goal. What tools did it use? Did it follow the steps in the right sequential order? Did it call the tool you were expecting it to call? And then the single step, which is white box evaluations. And this is about going into the individual steps. If you have like a router, like there are a reasoning step that goes through either answer or tool call. Is it routing to the right place? Is your retrieval step getting the right data? Um, there are different types of evals. There's like the traditional NLP evals that are statistical evaluations. You'll often hear things like F1, Bleu, or Rouge, or Meteor. But these are basically going to do like statistical analysis of your text compared to a ground truth. They're extremely cheap to run or quick to run because they don't require any AI behind it, but they're also not that accurate because all we're doing is comparing words, comparing overlaps, comparing like n-grams. They would be a good indicator that something is off with your agents, but they're not really a good source of truth. We want to, when we want to set up these NLP evaluations, we can do this pretty easily with Microsoft's AI evaluation library. That allows us to quickly set up like a F1 score evaluator and get a score out of it. So these are the evaluations that we're going to run with our agent in just a few minutes. Trajectory evals, what you want to do is extract a list of steps that we're taking to get to your answer and have also like an expected steps that are paired with it when you're running your evals. So you can do exact sequence match, which is like a very strict match of all the steps that we're taking. You can do like ordered subsequence if you have like a multi-agent systems. Maybe you're just interested in the tasks that were delegated to the right agents. And then you can do a set match, which isn't necessarily looking at the exact tool matches, but it assumes that you've called at least a set amount of tools that were supposed to be called. And then finally, LLM as a judge. This one is probably the most powerful, but also very error prone and expensive. But we're using another large language model to give a judgment on whether or not like the answer was relevant, if it was coherent, if it was grounded with the right information, if it was correct. What you can also do is send out the full trace for evaluation to the agent. It's super powerful again, but very error prone. One example of white box evaluation is the RAG triad, which is evaluating multiple steps within your retrieval pipeline to determine if they make sense. So you would be evaluating what happens with the query versus the context that was retrieved to determine if the returned results from your retrieval tool actually made sense. On the other hand, with context versus response, you would determine if the response that was provided was grounded with the context that was retrieved, or if it hallucinated any information. And then with the response versus the query, this is sort of our black box evaluation, but determining if the response that was given or if the information that we've retained was relevant to the query itself. So we're going to do a quick evaluation demo of evaluations. I'm going to go back into the code. Okay. And what I have set up in LangFuse is a data set. Actually, we should probably just jump into LangFuse. Okay. So what we have in here is a data set. And this is a retrieval data set that I have. And like I mentioned earlier, this agent has access to like a web search tool via Tivoli. And in my data set, I have two items. One of them is who is the president of the company Carl Lapierre is working for, and who is Carl Lapierre. One of them is quite easy to figure out. It's if you do like a quick search via the search tool. I have a trajectory that's set up that says that it should do at least one web search. And I have an expected truth here that says Carl Lapierre is a lead AI engineer at Obsidia. Also, who is the president of the company Carl Lapierre is working for? This time, I'm expecting the agent to reason and make two different calls. So one of them would be to figure out where I work, and then the second one is to figure out who the president of the company is for where I work. And the trajectory I'm expecting is to do two web searches. So when I run these evals, I have a couple of evaluators set up. I'll jump into the code. Stop here. Okay. So what I have here in this this setup, this project, I'm going to share it by the way, but it's like a custom evaluation framework. It's not from a specific vendor or anything, but I set up a couple of evaluators. One of them is Bleu, Gleu, and F1, which come trajectory evaluations. One of them is strict and one of them is unordered. And then we have the triad evaluations. So for answer relevance, for context relevance, and for groundedness. And what I'll do is run experiments on the data set for the retrieval data set. What this is going to do is it's going to pull the data set from LangFuse, and it's going to take the agent that I've had earlier. It's going to run the conversation history versus the agent, and I'm going to retrieve a trace ID, which I'm going to assign to this data set run. And in my data set, I'm going to have all of these runs logged with the results. So 2 items are run. I have the ID of my run, and what I'm going to do is run the evaluators, not the list of evaluators. Experiments, sorry. Just going to find my, okay. I'm going to evaluate against this data set. There we go. We'll see that since I have all of these evaluators registered, it's going to pull those 2 traces that I created and run all these evaluators against it, and then assign a score for each trace depending on the score that I got back from my agent. Okay, now we're going to go back into LangFuse. And good. So if I go back to my data set and open it up, I'll see that I have a new run here. If I open up this run, I have a bunch of different scores. And already I can see that something is off because I'm getting some red, which means that something's didn't come out properly. If I look at the result of this generation, I'll see the president of the company Carl Lapierre works at is Martin Coulomb. So it got it exactly right. And if I were to look here, there's a correctness eval that says the generation exactly matches the ground truth statement and contains all the required facts. F1 score is pretty high up. Same thing for Gleu. I'll talk about language eval in a bit, but the trajectory also matches exactly what I was looking for. It did 2 subsequent searches. Same thing for unordered. And then we also have the answer directly identifies the president of the company Carl Lapierre works for, which is exactly what the user asked. So this is the answer relevance compared to what we asked. And all in all, we have some pretty good results. We do have groundedness here results that aren't matching properly. So what we can do is go into our trace and look for groundedness eval. The groundedness evals happen directly on retrieval steps. And I can see that in this case, the web search for context relevance worked. It was true. But if I look here in the groundedness, I would see that the generated output states that Carl Lapierre works at Obsidia as a lead AI engineer, which is unsupported by the retrieved context. So it essentially assumes that I work at Obsidia when it didn't actually get that from the reasoning from the web search that we did, which was just for Obsidia, president or CEO. Um, Now let's look at the answer was still good, by the way. So that's just the retrieval not necessarily being tweaked properly. But let's look at this one here. Um, I did a search for who is Carl Lapierre, and I got all immediately Carl Lapierre is a Canadian professional ice hockey player known for his role in the NHL. There's no NHL player with my name in the NHL. There's Maxime Lapierre, but there's no Carl Lapierre. And if I look, I'll see um, that it's straightforward. There's no, the trajectory hasn't matched. It's false. So if the trajectory hasn't matched, that tells me that I should be looking at the tool calls in the trace. When I look through the tool calls, I'll see that there's no tool calls. This means that our LLM specifically answered the question without actually retrieving any information um, from the with the web search tool. So if I go back into my prompts, which are all fed into the agent that I'm working with, and I change my prompt, this was the original prompt. I can promote a prompt so that it tells exactly that it should reason and look through the web search tool if we're looking for information and not to use any like training data um, to answer questions. If I do this and I rerun the experiments, then my scores are going to be correct. It's 1 o'clock. I know it's a bit late, so I'm gonna have to stop it here. I don't know if anybody had questions or something like that, but I just realized that maybe this presentation's too long.
Uh, you already all all of my question because along the presentation I write some question. But
Yep.
if someone have a question, you can open your mic, I think.
Yeah.
For my point, if nobody have ask question. I note that the main issue in the world of AI agent is that we are accountable without having deterministic response.
Hmm.
Thanks to those monitoring tools, we can understand and see if you are better in the relevancy and accuracy of the response. Like your example of Air Canada and the wrong answer in the reimbursement policy, we have seen, we have saw this thanks to the prompt detail in the trace. Yeah, you can see the detail of the prompt in the trace. And you have answer how we can put some alert or signal thanks to the tools. I saw that for the alert, I see that I notice should we provide business value in the order to evaluate the response, for example, and the response is a data set. We have seen this.
Yep.
So yeah, and to how we can impact or change the reasoning of the agent. I see that we can use the levels of evaluation NLP and the data set. And to fix it, we can increase our prompt thanks to the right response. Yeah.
Yeah, that's a good resume of the presentation, but also some things that I haven't covered is the human annotations as well. And I wish I could have spent more time on that, but sending it off to a subject matter expert to offer its own evaluation. But also, these platforms allow you to quickly set up LLM as a judge on live traces. So as they're coming in, um, let's say in this case for um, the manual trace that came in, I have one evaluator that runs for everyone, which is a lightweight evaluator that just determines if the incoming message is answered in the same language as the output message. But you can do things like that, and the same thing happens for correctness. You can have LLM as a judge on dataset experiments that are running automatically um, to do these evaluators like directly in these platforms. So I wish I could have covered this a bit more. And yeah, ultimately these need to be treated as signals. The scores need to be treated as signals and not like sources of truth. There are like false positives, and also there can be issues where your LLM answers correctly in the first go, but it doesn't answer correctly in the second go. So running multiple experiments can also be important to get like more consistent results, so that like the results converge towards like the right signal. Yeah, not enough time to talk about that, but thanks for listening, and also I'm very happy that I got to share this and know that I need to condense this a bit more.
I have other question, but
Yeah, go
I
for it.
think we missed the time. Can you continue, or you need to leave?
Yeah, I'm good to continue
Okay.
if you want to
So
talk about it.
just for the LLM as judge, we keep the human in the loop, or you can set some threshold to accept some answer and improve your agent prompt? Or
Sorry, can you repeat? I'm not sure I understood.
yeah, you said that we can use LLM as judge,
Yeah.
but the goal is to for maybe configure some threshold to accept some answer and improve automatically the model. Or
Oh, I understand what you mean. Um, it you can't necessarily configure a threshold in this specific setup. What you can do is set up dashboards and have like some alerting. But it won't lead to like further automations. But the dashboards are like fairly extensive, and they can tie into like experiment runs. And also you can configure the scores that your LMS judge will give, so that it's not just pass or fail, but like a gradient between 0 and 1. Um, so like a scale between 0 and 1, so that if it passes at like 70%, then maybe you'd want that to appear in a dashboard specifically, and that could lead to like further automations. Um, but yeah, but maybe what can be done is like one evaluation leads to another like type. What I showed in the code is that you can specify which evaluations you want to run. Um, So when you run an evaluation, you have access to all the context of like a trace, which also includes previous scores. So if you run like a second set of evaluation on something that's already been scored, then maybe you can have like different automations that come after that, if that makes sense.
yeah, and just for the evaluation, we need to share business value and data, for the data set.
Hmm. Sorry?
In order to evaluate the response, the right response,
Yeah.
when you make an evaluation, you provide some data set, but you
Yeah.
need to provide also that business value, or not fake data.
Yeah. I should have led with this, but when you're getting your incoming traces, you can go in here, and there's a add data set which converts your entire trace into something that you can add to your specific data set. So if I had the retrieval data set here, and this was, let's say, something that I had feedback on from a customer that said, "Oh, there's something clearly wrong. There's a hallucination here. It's bad." Then I would add it to a hallucination data set and run some custom evaluations, um, so that when I make my improvements, I know that that specific business use case was handled.
I have also two other questions.
Hmm.
The first one is, what about the other existing tools that analyze calls behind the first call, like Datadog or Dynatrace? Do you think we need to use for agents new tools, or we'll have some integration? Because for our attendees and companies,
Yeah.
this means that we need to integrate new tools also in the
Yeah.
system.
Not necessarily first. Not necessarily. You don't necessarily have to. I've looked into Datadog and like Dynatrace and what they offer, and it's fairly extensive.
Okay.
The same thing as what Azure AI Foundry is currently offering. They're all of these providers are adapting to the new reality of like AI agents and how to observe them. So it's only a matter of time before they all offer the same type of support. Um, So I wouldn't say like absolutely need to adopt a new tool. It's just some of them are very um, specific to evaluating agents like LangFuse, and features are being actively developed on this since it's an open source project. That they're really benefiting from the entire community working on these integrations. So yeah, you don't
Okay.
have to, but you'll get an advantage, I think, if you're using
Okay.
like a more focused system.
Or just raise the integration of the standard thanks to OpenTelemetry. Yeah.
Yeah.
And the last one, it's on the correction of CVE and zero-day vulnerabilities. Do you think this kind of tools can help also? Or-
Um, yeah, I think so.
Okay.
It's well for vulnerabilities um, like th these are great platforms for like red teaming and making sure that your agents aren't vulnerable to like malicious intent. There are like even evals that are pre-made to evaluate your agent behaviors like this. And the same thing goes for AI Foundry. There's a whole section dedicated to agent safety and ethics that you can put in place. So, but yeah, absolutely, definitely,
Okay.
it's not. Yeah,
Okay, thank you so much, Carl. For me, the evaluation part was so interesting. Yeah, we
yeah.
the demo part. I think it's very useful to see a concrete example to see how we can debug and see the detail of a prompt and how we can improve it. Yeah.
Thank you, thank you. And I definitely will put more emphasis on the eval part. I think that's the most exciting one as well, and I didn't have enough time on it. So thanks,
Yeah.
I appreciate it.
Thank you so much. Thank you
Yeah,
so much. And
take care.
I
Bye.
will see at the next meetup. Bye.
Yes, bye.